All right, good morning. Happy Thursday. Here's some announcements. First of all, you are responsible for the problems that I'm giving in the assignment. You are welcome to work more. Notice that I'm not assigning the evens right now. So obviously, the more problems you work correctly, the more opportunity that you have of getting problems correct on an exam. So I'm assigning the minimum amount of problems that I think is necessary for you to be successful. But obviously you should work problems over and over again. Lots of times students will say, well, I've already done the assignment. I'm like, well, do it again, and then do it again, and then do it again, and then do it again, and keep working problems over and over again, because that's how you build your confidence. So confidence comes from working problems perfectly and working them over and over again so that it seems like a routine. Yesterday, I had some students leave the group meeting early, and those students were marked absent. So I'm just letting you know that I'm a leader, and if we go into the groups and I tell you to leave at the end of class, that's exactly what I mean. We can't have too many leaders, so I'm capable of leading, and I need you to follow the leader. Okay, so don't go off on your own page anywhere. Make sure you're listening and following directions. Also, I noticed yesterday in the team meetings that there was a lot of background noise. And I know for some of you, it's inevitable, you can't help it, but I really need you to talk to your parents. And if possible, during a class meeting, try to keep the surrounding area as quiet as possible. And like I said, this is easier said than done. But honestly, I really don't think parents know what you're going through. And they don't know how distracting, yesterday I saw, someone with their dog in the background. I saw somebody running back and forth trying to get an outfit ready. And it's that all of those types of things are not what would happen in class. And so we want to try to eliminate all that noise, those distractions, if we can. And you're going to have to explain to your parents because they don't understand. Also, back to school night, which is coming up, I am going to explain to the parents what I need from the parents. So normally I talk to the parents about what I need from you, but I'm going to be talking mainly about what I need from them and how they can help you to be successful in the class. When you are in the team meetings, remember that you can share your screen and you can go on to the online textbook. So if you go onto the online textbook, you can hit on the globes and do the problems that are online with your team. So that's a really good way to practice problems also, and to get up to speed for exams. I don't know if you noticed, but when you ask me questions, especially about exams, I'm going to give you hints. And so in other words, I'm rewarding you. The more questions you ask, the more hints you get about an exam, and it just makes you test wise. In addition to that, I don't know if you know this, but the people that ask the most questions are not the ones that are confused. The people that ask the most questions are the ones that are usually my top students. All right, I think that's it for that. All right, so on Friday morning, which is tomorrow, you have an exam, P.1, at 8 o'clock in the morning. Now, this is important. You have to set your alarm. You might want to set a few alarms because you cannot miss this exam. So if you do miss this exam, you will get a 0. I'm not offering the exam later. So unless there's an emergency, and I'm talking about emergency like an ambulance, police incident, God forbid something's happened to someone around you. I'm talking about a real emergency. You have to take this test at 8 o'clock tomorrow morning. Now, yesterday I took you through Google Classroom and I showed you how to actually get to my math lab. And so all you're going to do is use your username and password, get on there and take the exam. It will start at 8 and it will shut off at 9 o'clock. And then you will have 15 minutes to take pictures of your scratch paper and submit them in Google Classroom. All right. Yeah. So make sure you're ready to go for the exam at 8 o'clock. The scratch paper has to be legible and clear. I will not look at it. If it confuses me, I'm not going to spend an hour trying to figure out your work. That's why we've been practicing with the assignments. So you would know how to do the scratch paper on the exam. So make sure you turn in your scratch paper if you want credit for the exam, and make sure it's legible because I will be looking at it. So make sure that it's legible for me to read. Now, I know which problems are simple and which problems are more difficult that require work. So if it's a simple problem that doesn't require work, like true or false, then there's no work to show. You just mark the answer and move on. If any problems require work that I feel is necessary, you must have them on your scratch paper. So in other words, this isn't like a normal multiple choice where you pick, okay, 1 is A, 2 is B, 3 is C. You have to show your work as if it were an open-ended test. So you have to write the original problem. You have to write vertically. You have to circle your answer. So you have to work it like you were at school taking an open-ended test and giving it back to me on paper. All right. Last but not least, make sure you're registered for my math lab. I helped 3 people yesterday register. It's not a big deal. If you need help, you need to get it immediately because you do have to have a My Math Lab online account in order to take the online exam P.1. So hopefully you're all registered. If you're not, you need to contact me immediately. I'm done teaching today at about 2:15. So make sure you contact me. Otherwise, I'm assuming that you're all registered and ready to go. Okay, once again, if you're having somebody, excuse me, somebody asked me what a hotspot was, and it's free internet. So if you're having problems with a Chromebook, you don't have a book, or you're having trouble with Wi-Fi or the internet, you can go to the Rancho bus loading zone because the district's giving away free hotspots, which is free internet. So there's students every day that are saying, oh, well, my internet messed up, it logged me off. So the thing is the district's giving it away for free, so you're expected to get it. So if you need a hotspot, free internet, make sure you get it, and you're getting that in the Rancho bus loading zone. Monday, Wednesdays, Fridays, from 8 to something. I don't know. I have it written on one of my papers, but hopefully you wrote it down there. It's on all the announcements. So if you're reading anything, you should see the announcements for it. Okay, I think that's it. All right, so first of all, I want to take any questions on P1 because today I'm going to teach lesson P2. So any questions about P1? No questions about P1? You guys are hanging in there? All right. Last call. Any questions about P1? Okay. All right, let's go on to lesson P2 then. If you recall what I said before, I'm not really doing a lot of teaching right now because these are all prerequisite skills, and I don't want to take a lot of time if you already know these things. So, but I am going to talk about the properties of exponents. I did put them in Google Classroom under materials. So there are, I think, 7 properties of exponents, and I want to go over each one of them right now. Just the simple property. Your problems are more difficult than this, but I'm going over the simple properties. Okay, so the first one is the negative exponent rule. You guys are writing this down, right? So whenever I'm writing, I'm not writing it for myself. I already know it. So the negative exponent rule says this. If you have something to the -1 power, you can write it as 1 over the positive b. So an example of this would be 5 to the -1. So 5 to the -1 is 1/5. Okay, to save room, I'm just going to write over here. If you have AB to the -1, the whole thing is raised to the -1 power. That would equal 1 over AB to the 1 power. So really that's all you do is you flip it to the bottom and make it positive. So let me do one more. Let's say you have 2 to the -3 power. What you do is you flip them on the bottom and make the exponent positive. So this would be 1/8. You guys see that? Try not to write that low. 1/8. Okay, that's the first property of 7. All right, the second property is the 0 exponent rule. All right, and the 0 exponent rule says that if you have b to the 0 power, so that's any number to the 0 power, the answer is 1. Now, b, as defined, is any real number, or, well, it's any real number other than 0. So you can never have 0 to the 0, but you could have 1 to the 0, 5 to the 0, 7 to the 0, 100 to the 0, -2 to the 0. So in this case, if you have 25 to the 0 power, the answer is 1. If you have, let's say, a quantity like 2xyz to the 0 power, that quantity is to the 0 power, so the answer would be 1. So that's pretty simple. So anything to the 0 power is 1. Now, I'm really hoping that you had these in Algebra 1 and Algebra 2, but I'm not sure what's going on in the math classes today, so that's why I'm going over it. I'm not going to assume you know it. All right. The third one is called the product rule. Okay, and the product rule says that if you have something to the m power times the same thing to the n power, the rule says that when you multiply monomials, a monomial is one term. When you multiply monomials with the same base, you keep the base and add the exponents. So I know that's weird, but even though you're multiplying monomials with the same base, you add the exponents. So let me show you. Let's say you have 2 to the 6th times 2 to the 9th. You're going to keep the base. This is the base of the exponent, right? So I like the way they use b because it is the base of the exponent. So you would add 6 plus 9, and you can write it, but normally we don't write it. We just do it. So this would be 2 to the 15th power. And I'm not going to make you multiply that out. I'm going to assume that you can use a calculator. You would write 2 caret 15 and multiply it out. But I don't care if you multiply it out or not. So the rule is in this class, if it's a little power like 2 cubed, multiply it out. 2 to the 4th, multiply it out. Even 2 to the 5th, you should multiply it out. But some huge power like that, don't waste your time. Okay, so let's say you have c to the 4th power, and you're multiplying c to the -10th power. Well, I just showed you the negative exponent rule, but we don't want to do that. We want to use the product rule. We always save the negative exponent rule till the end of the problem. So the product rule says keep the base and add the exponents. So 4 minus 10 is -6. And now we're going to use the negative exponent rule, which says flip him to the bottom and make him positive. Now, let's say you have a problem with the negative exponent on the bottom. You would flip him to the top and make him positive. So a negative exponent on the top, because this is over 1, right? The negative exponent on the top flips to the bottom, becomes positive. A negative exponent on the bottom would flip to the top and become positive. All right, we have 7 to go. This is number 4. All right, number 4 is the power rule. The power rule says that if you have the base of the exponent to the n power and that's raised to the n power, so in other words, a power to a power, you just multiply the powers. So the answer would be m times n. So an example of this would be 2 cubed to the 7th power. The answer would just be 2, and you're not adding the powers like we did with the product rule. You are multiplying the power, so that'd be 2 to the 21st power. We're not going to multiply it out. If you have t to the, let's say, -2 power to the 9th power, don't flip it. It just causes more work. It would be t to the -18th power. And now that's considered not to be simplified because you have to use the negative exponent rule. So what you would do is flip him to the bottom and make him positive. And like I said, you want to save the negative exponent rule till the end of the problem. So you use all these other properties, these rules, and you save the negative exponent rule till the end if you want to do it the most efficient way. So we're on number 5. Okay, don't forget that when you study for the exam, hopefully you have been studying, make sure that you look at the assignment and click on those globes and do the problems online to practice. Okay, number 5, that was the power rule. Now we're looking at the quotient rule. Quotient means divide. So the quotient rule says this: if you have b to the m divided by b to the n, instead of adding the exponents like the product rule, we subtract the exponents. So the product rule, we keep the base and add the exponents. With the product rule, with the quotient rule, we keep the base and subtract the exponents. So for example, if you had 2 to the 6th over 2 squared, instead of multiplying them out and wasting a bunch of time, the quotient rule says we can just keep the base and subtract the exponents. So 2 to the 4th is 16. Okay, another example of this would be f, and let's do some negatives here. F to the -2 over f to the negative 5. We're not going to freak out about it. We're definitely not going to flip them around. So if you're thinking, let's put him on the bottom, put him on the, that's a bad move. What you want to do is keep the f and subtract the exponents. Now watch this. Wouldn't this be negative 2 minus a negative 5? Negative 2 minus a negative 5. So what you get here, board's wet. Right. So what you get here is you get f to the negative 2 plus 5, which is f cubed. So notice we never flipped anything. So we use the quotient rule, and we end up with f cubed. Almost there. This is number 6. Now the trickiest part of all this is being able to recognize, what rule do I use? You know, looking at a problem that may have 2 or 3 of these rules in it. Which rule should I use first? And which rule should I use second? Well, let me tell you something. 3 people might do it 3 different ways. So don't think that you're wrong. So when we go into the teams, if somebody does it one way, don't think you're wrong because you want to do it another way. But as teams, you have to concur on which way you're going to do it. When you're working by yourself and checking each other's work, you could have different ways of doing it. But when you're working in teams, you have to decide which way you're going to do it. Because you're working together. So, okay, that was the quotient rule. The next rule is products raised to powers. Okay, so this is what this says. This says that regardless of how many of these things you have in here, and it's raised to a power, like n, all of them, all of the product has to be raised to the power. So this would be a to the n, b to the n, c to the n. So an example of this is a very important one because you see this a lot. If you had let's say 2x, y, z raised to the 3rd power. The rule says this would be 2 cubed, x cubed, y cubed, z cubed. So the final answer would be 8x cubed, y cubed, z cubed. Now, let me show you something that students get confused about. In this type of problem, students want to deliver the power like we did here. So some students think that this is x cubed plus y cubed, and guess what? That is not true. So students get the rules mixed up. You cannot do that, and that's a very bold statement. I'm saying you cannot do that. What you would have to do is you would have to take x plus y times x plus y times x plus y, which is a long problem. So you would have to FOIL 2 of those. Then you would have to distribute the binomial to the trinomial. It's a 3 or 4 step problem. It's not that simple. So please don't do that. All right, I'm going to erase this one because I do want to do another problem like this with a negative in it. All right. When you look at this, you want to look at this as -1 times 3 times a times b. -1 times 3 times a times b. So there's 4 things that this 4 has to go to. So first of all, any negative raised to an odd power is going to be negative. And any negative raised to an even power is going to be positive. So let me tell you what I mean. This negative is raised to an even power. That means it's going to be positive. If this was a 3, 5, 7, then the answer would be negative. So if it's even, 2, 4, 6, 8, 10, 12, the answer is going to be positive. This is going to be 3 to the 4th, a to the 4th, b to the 4th. And your final answer would be 3 times 3 times 3 times 3 is 81, a to the 4th, b to the 4th. Okay, last but not least, is quotients raised to powers. So division raised to powers. So it's really similar to this one, but what you have this time is you have a over b with the raised to a power. And I'm just gonna put another letter under here just to show you. So if this was the rule, you would have to raise them all to the power. So this would be a to the n divided by b to the n, c to the n. So for example, if you had 2xy divided by, let's say BC, and let's say all of that is raised to the 3rd power, you have to raise them all to the 3rd power. So this would be 2 cubed, x cubed, y cubed, b cubed, c cubed, and then your final answer would be 8x cubed, y cubed, b cubed, c cubed. So same thing with the negative. So let's say you had negative 2/3 raised to the 4th power. You would have to raise the negative 1 to a power, so that's positive. And then you would have 2 to the 4th over 3 to the 4th. So this ends up being 2 times 2 times 2 times 2 or 16. And 3 times 3 times 3 times 3 is 81. And that can't be simplified. The factors of 81 are 3 and 9, and 3 and 9 doesn't go into 16. So, okay. So there you go. Those are all the properties of exponents. Your problems are going to be, well, like I said, it could include more than one. I do want to work a couple problems to show you how the properties can show up in, more properties can show up in one problem than just one property. I also want to talk about scientific notation because I know that you guys use that in your science classes, and I don't want your science teacher to go, Miss Birch, why isn't she teaching him how to, what's wrong with that student? Why isn't she teaching him scientific notation? All right, so. Let's see here. You do want to look at your book and look at these examples because I can't do them all right now. So make sure that you're using your book. So it looks a little bit tougher than what I did, right? So it's like, what the heck do we do? Which property do we use? And how do we know what's going on? Well, first of all, this times that, we want to multiply. So a -7 times a -2 is a +14. And now we're going to use the product rule, which says when you multiply monomials, you add the exponents. So this would be x to the 1. So 1 + 5 is 6. And then we multiply by adding the exponents, which would be 6 + 4 is 10. So that is your final answer. And we know we're done because no other properties can be applied. I'll do one more. This is 4x squared y, and this time it's to the -3 power. So I'm going to show you something different than the book, because I really don't want to deliver a -3 to everybody. Like normally we don't like delivering negatives. Notice I'm not saying distributing, I'm saying delivering, because the distributive property is this one. This is the one you're going to be tested on, right? So this is not the distributive property. The distributive property is something across the sum or difference multiplying. This is a power that's being delivered to parts of a product or quotient. So let me just tell you this. This guy is going to be, everybody's going to get that -3, and he has to flip to the bottom. And this guy's going to flip to the top and become a +3. And like I said, you don't have to do it this way, but I'm just showing you the best way to do it. So your answer would be y cubed over 4 cubed x to the, and you multiply the powers, x to the 6th. You have to multiply this out. I'll write it over here since I don't have room. This would be y cubed. 4 times 4 times 4 is 64. X to the 6th. Okay. Anybody want to ask me any questions about this? And you may not have questions now, but you will. Just like I said, there's a bunch of different ways to do it. Normally, you don't flip things until the end, but I noticed on this problem, I don't want to deliver a negative exponent. So I decided, hey, everybody's going to get a -3, so he's going to go to the top, he's going to go to the bottom. Turned out better to do it that way in that particular problem. All the problems are different. See, that's what's hard about Algebra 2, is that all the problems are different. It's not like first grade where they give you 10 of the same problem. You know, all the problems are different. All right, so let me talk about scientific notation. Basically, scientific notation is a way to write a huge or very small number. So if we were talking about something that was microscopic, that we can't see with the human eye, it would be a very, very small number. So we want to use scientific notation rather than using 0.0000000216. If we were a aerospace person and we're talking about the distance from here to Mars, or the distance from here to some distant galaxy, we don't want to write this really huge number. We want to use scientific notation. So basically the rule says that a number is in scientific notation if it looks like this. But there's a condition. A has to be between 1 and 10. So I'm trying to figure out how to write this. So this has to be less than 10. And greater than 1. So how I'd write it is it has to be less than 10 and it has to be greater than or equal to 1. So this is the condition. Okay, so for example, if we had this, and they want us to write that in scientific notation, that's our, we use the decimal system. That's not in scientific notation. The reason why it's not, it doesn't fit this form. So what I'm going to do, I'm just going to move it over there. So I'm going to change it to 1.35. Now that's greater than or equal to 1, right? Okay. And so the question is, how many times did we move it? Well, if you count, you go 1, 2, 3, 4, 5, 6, 7, 8. And the question is this a really big number or a really small number? And this is a really small number, so this has to be negative. Now, I did not learn it this way, and I don't teach it the way I learned it. Teachers tried to make me memorize. Well, if you go to the right, it's negative. Go to the left, nobody remembers anything. So we're going to use common sense to remember this. Okay, watch another example. 1, 2, 3, 7, 5, 8, 0, 0, 0, 0, 0, 0. And this number is a big number. So it definitely doesn't fit in my form. That's not between 1 and 10. So I'm just going to make it between 1 and 10. There. Those trailing zeros are insignificant. So it's like, okay, well, we have to put times 10, but how many times did we move? We moved 3, 6, 9, 10, 11. So the question is this a really big number or a really small number? Now, this is a really big number, which means that what's equivalent to it is a really big number. So this big number is equal to this big number. This small number is equal to this small number. So we're just using common sense and our knowledge of what equal means. Couple more problems and I'm done. They may want you to multiply numbers in scientific notation. So they might give you this. They might say, okay, well, given 6.1 times 10 to the 5th, that's a big number. They want you to multiply 4 times 10 to the negative 9, small number. Well, we're not going to write it out as a decimal. We're not going to expand it out. That's 4.0. So watch what I'm going to do here. I'm just going to say 6.1 times 4. You can use a calculator. So you're going to do 6.1 times 4, 24.4. And then we're going to use the property that we just learned. So when you multiply monomials with the same base, don't you add the exponents? So would this be 5 plus a negative 9 is negative 4? So it's like, oh, we're done. No, we're not. Remember, this has to be between 1 and 10. So this is, it looks like it's in scientific notation, but it's not. So we have to write it in scientific notation. And I just made 24 2. So I have to make it big again by adding 1. So let me explain that again. 24 is not in scientific notation. So when I moved the decimal and made it 2.4, the question is, did I make a bigger, the comment is, I made a bigger number smaller, so how do I make it big again? Like, how do I compensate to keep the equality? So if I made a bigger number smaller, I have to make it big again by adding 1. So your final answer in scientific notation is 10 to the negative 3. Same thing with division. If you have 1.8 times 10 to the 4th divided by 3.0 times 10 to the negative 2, we're not going to write it in a big old long decimal. We're going to use scientific notation. So on the calculator, you take 1.8 divided by 3, and I'm doing it for you. It's 0.6 times, and when you divide monomials, remember when you divide, you subtract the exponents. So it would be 4 minus a negative 2, which is 6. But back over here, that's not in scientific notation. I have to move it to the right and make it a 6. So this ends up being 6 also. But here's the deal. I just made a small number bigger, so I have to make it small again, right? So how do I make it small again? You would subtract the place you moved, which was 1. And so your final answer is 6 times 10 to the 5th. So in other words, if you move the decimal, you have to compensate the 10. You can't just move a decimal and get the same answer. I mean, if you're going to keep the equality, if you move a decimal, you have to compensate for it over here some way. Okay, I'm going to stop. Anybody want to ask me any questions about anything?
Ms. Birch.
Yeah.
So for the last problem that you did, how did you get 0.6? Did you 1.8 by 3?
Yeah, exactly. I'm going to check it just to make sure now that you're asking me. So you take your calculator, take, 1.8 divided by 3 is 0.6.
Yeah. And then you move that point to the right, subtract. That's how you get.
But you know, we don't want to try to memorize it. That's what my teachers tried to make me do, and I couldn't remember. So watch how I'm teaching it. 0.6 is 6/10. So 0.6 was made bigger. So 0.6 was made into a 6. So in order to keep the equality, we have to make it small again by subtracting. So since we moved the decimal, I made a smaller number bigger, so I'm compensating and getting it smaller again by subtracting 1. Like up here, I made 24 2. So how do we make it big again? You would have to add 1 because I moved it 1 place. So remember, you want to keep the equalities. And in my opinion, rather than memorizing left and right, I would just be logical and just make sure that your equality, if you change a big number to a small number, you have to make it big again. If you take a small number and make it big, you have to make it small again to keep the equality. All right, any other questions? Okay, let me take you into the classroom real quick. Share my screen. Okay, I haven't posted this yet because you have a test and I know you probably want to focus on your exam. But I'm just basically kind of telling you that this is the second review, and I've included the properties of exponents down below here. So if you look here, see this document down here? I did put the properties of exponents in here. So here's all the properties that I talked about today. There's 7 of them, and I put them in this lesson for P2. So basically, I'm going to be assigning page 31 through 105 odd, which is the way you figure it out. You take half of 105, which is what, 52 with 1 remainder. So there's 53 problems. And I'm saying that up here. I'm saying that I am assigning 53 problems. In this case, there's 3 objectives and 5 different sections. So. Okay, so I will sometime soon change the math teams because I do want you to have the opportunity to work with everyone. But I feel like we're still just being trained on how to work together. So in the teams, you can actually work problems from P1. And even if you've done them, I want you to work the same problem. So I want one person to pick a problem and you're all going to work it. And then I want the next person to pick a problem and you're all going to work it. And I want the next person to pick a problem, you're all going to work it. Now, let's say that everybody feels like I'm going to get an A on this test. I don't need to study for it anymore. I've studied. I'm going to get an A. I don't need to look at it anymore. Then you guys can start on P2, the odds. And so you can start on the assignment and you can start the odds and start working on that assignment. All right. So remember that you're in Google Meets, so you can share your screen and actually work the online problems. Let me show you. Let me show you something. I'm in WebEx, but let me show you what I'm talking about. If I know where to go. Okay, bear with me. All right, I'm going to share my screen. I'm going to go here and I want to, actually, I don't want to go there. I'm just going to add a new tab and go into My Math Lab. So this would be what you're going to do when you sign in for the exam. So yours looks real similar to this. Remember that if you forget your password, do not ask them to send it because the district will block you. If you want to ask me for it, that's why you filled out that form. So you would be signing in just like this for the exam. Precalculus. Okay. You should see tomorrow, you should see the test come up. Oh, here it is. Nope, it's not there yet. So they told me that it would be there. So hopefully it will be there. But this is, you're going to see it. You're going to see it on this screen. And then you just take the exam. And that exam is P1. Okay, now that's not what I want to show you. I want to show you something else. So if you go to the e-text. Now remember, you're in your groups, in your teams. I have a lot of things open, so it may take a minute. Hopefully this will load pretty soon. Okay, so I'm going to go to page 17. That's P1. And we could say, okay, well, somebody in my group or me, I don't understand these problems. So I don't understand 1 through 16. So I want to do a problem out of this. I want to do number 6. Okay, well, there is no number 6. So let's do number 7. So what you could do is click on this. And everybody's going to write this on their piece of paper. So everybody's going to write. Now remember, you're just practicing. So you would write example. You could put 1, and you're going to write the original problem. You're going to work the problem vertically and circle your answer. So there is work to show on this. So you have to substitute 6 in wherever you see an X. You're going to work vertically and circle your answer. And in your team, you're going to talk out loud and make sure you guys all get the same answer. Okay, what I don't want is you to work the problems individually. Everybody gets a different answer and you have to do it again. I want you working together and get the right answer on the first shot. Okay? All right, so let me get out of here. All right, I will see you in your teams. It's 10:18 and you have more than a half an hour to do this. So make sure you don't leave early or be marked absent. And I'm going to just give you, kind of going into snail's pace here, I'm going to give you time until the end of the period. So we will not report back here. You will stay in your teams till 10:45. And at 10:45, you can leave. Remember that if you need me, send me a remind and I can work any problems you need me to work. Okay, and remember, the more questions you ask, the more advantage you have of knowing what's on the test. Okay, so I'll see you in the groups. You can leave this meeting. I'll see you in the groups.